Hello, I've had a question from Unit 1, Lesson 4. This is projectile motion, number 32. I need a diagram here. It says a bag of mail is catapulted from the top of a building 200 meters tall. There's my accurate drawing of my building. It has a velocity of 20 meters per second. And it was launched at 15 degrees above the horizontal. So I'll give you some components. The mail, if the mail is to land on the roof on another building 100 meters away, so here's 100 meters, how tall is the second building? So I assume we're going to just make it land on the lip, so since we don't have enough information to make an accurate measurement here. So let's say it's going to land right on the lip. Anything a little bit over, we will be just fine, or I guess we'll be looking at maybe being shorter. So this is projectile motion. It is important to break it into your horizontal and vertical. Should be the first thing you're doing. So I know my horizontal velocity. That's going to be 20 cos 15 meters per second. Distance, I know my horizontal distance. It's going to be 100 meters. That's to the right, both of those. So now I can figure out my time that the bag of mail is going to be in the air. Since there's no acceleration in the horizontal, d will equal vt. 100 equals 20 cos 15t. T will equal 100 divided by 20 cos 15. So we find that the time in air is 5.17, so let's say 5.2. But we'll make sure it's in long enough maybe to get it just off the lip a little bit. So there we go. We now know the flight time. I can now move to vertical because there's nothing left to solve horizontally. So velocity vertical will be 20 sine 15. And this is where most people make their error. This is up. So our sines are going to play a huge role when we go into the equation. Delta D, this is what we're looking for. We want to know how basically the height distance between the two when the mail is launched for a total of 5.2 seconds. With the vertical, when acceleration is involved, you need to know 3 of the 4 unknowns. And in this case, we do know acceleration. And we'll assume it to be 10 meters per second squared. And it's going to be down. So the reason we have up and down, we can say that this is going to be positive value. But because this is down, acceleration is going to go into my equation as a negative. So the equation we're going to use, delta D equals v1t plus 1/2 at squared. We're looking for delta D, so that's not the problem. Velocity is 20 sine 15 times time, which I believe was, what was it, 5.2. Clean that up a bit, 5.2 plus 1/2. Now this is where it goes negative 10, and my time, 5.2 squared. So we can punch that into the calculator, and we get 20 times 5.2 times sine 15 bracket plus bracket 0.5 times the negative 10 times 5.2 squared bracket. And I get a total of negative 108.3 meters. Now remember, we're finding or we're determining how far the mail fell in that 5.2 seconds. So it fell 108.3 meters. So that means that the second building height, so therefore the second building can have a max height, because this is as high as it can be, max height of 200 minus the 108.3. So therefore, does that come in? 91.7 meters tall. All right, so that gives you that height. So that means in this building, in order for the mail to be up there, it can't be over 91.7, or it's going to hit the face of the building. So we got to make sure it doesn't extend beyond that. If you have any questions, let me know, and I'll try to clear them up.